Hello again. Let's do another velocity problem. This time we have to work the formula a little bit, so we'll see how we do that. So a car moving at 23 meters per second travels 7.6 kilometers. How long does this take? We start by writing the word givens, keeping it neat, underlining it, put down what you have. Well, 23 meters per second. What is that? That is a velocity. So V equals 23. Make sure you keep the units. Also, the units, when you write them down, if they're in a form like this, you never use a diagonal slash line. It is this with a horizontal line over this. The reason? You do not ever want to get confused as to which is on the top and which is on the bottom. This makes it extraordinarily clear. Let's not cause ourselves undue grief. A horizontal line makes this clear, and the clarity is everything here. It travels 7.6 kilometers. What is that? That is a distance. So distance equals 7.6 kilometers. Do we have any trouble with that? Well, yes, we do. It's not in meters. How do we fix that? Let me ask you, what do you suppose we multiply by? Yeah, you. The one who said 1? That's right. We multiply by 1. So, kilometer goes in the bottom, so we'll cancel. Meter goes in the top. How do we make this number 1? Well, 1,000 meters is the same thing as 1 kilometer, so this has a value of 1, so we're not going to be changing our distance. We're just going to be changing our units. So when we do that, we have 7,600 meters. The kilometers nicely canceled and went away. And now we can write that we seek to find out what the time is. How long does this take? That's time. So the formula, well, now we have to rearrange the formula. We start as it's written, V equals D over T. But we have to rearrange this algebraically. So how do we do that? Well, we have to get the T out of the denominator. So if we multiply both sides by T, that's a good start. T over T is 1, so that cancels on this side. So if we rewrite T times V equals D. Now, I could do this faster, but we never want to get this wrong. So make sure you're doing it in a way that you do not get it wrong. Divide both sides by V. The V's cancel because V over V is 1. And we end up with T equals D over V. Now, were we 100% sure this is correct? Well, we're pretty sure it's correct. But when we put the units in, if the units work out to seconds, that means we are completely correct. So that is always our last way of making sure we are correct. Substitution and solution, we can just write it S and S, and we rewrite our formula for it. T equals D over V. And we substitute in. D is 7,600 meters. And notice, so, while there's 4 significant figures there, that's a lie. There's only 2 significant figures there. Okay, good to remember. We're dividing that by the velocity, which is 23 meters over seconds. All right, so what do we have there? 7,600 divided by 23 equals 330.4. Well, how many of these are we allowed? Well, we're just allowed 3 of them. We have 2 significant figures there, so we could say 330 meters per second. Knowing that this number is vague, these numbers we're certain of. 330 meters per second. Oh, and I am sorry. I am dreadfully sorry. What did I mess up on? Can you see? Can you see what I messed up on? I hope you can. What did I lack here? I didn't do my units. So we invert and multiply. That's seconds over meter. This meter was over 1. The meters cancel. We are left with seconds. Whew. See? Watch those units. If you mess up on the units, Nothing else works. So even though the number was correct, if I were to ever put that as meters per second, is that a time? No. This entire thing is wrong if I do that. So we have to be careful. The last thing you look at, you might be careless. Like I was just being careless. I put meters over second, wasn't even thinking, but I'm looking for time. Meters over second does not equal meters per second, never could. So you invert and multiply, and that is how you do that. So we end up with seconds. Is that what I want? Yes, that is correct. And I didn't end up with a mistake there. So thanks for watching.